Hello, my name is Werner Otaville. Today I will be displaying comparative effectiveness. Today in our learning objectives we will present and illustrate how to conduct match controls through cases in Microsoft Excel. I will be displaying this using the Kaplan-Meier survivor estimator plot. In our matching criteria, controls will be matched or they will be variable with cases. This will eliminate any disparities that might occur with the study. Many studies in the sample population are conducted to mitigate variable interaction, such as gender disparities, comorbidities, or even death. In our sample case, we will be using two patients who will be identified as control matches for the cases. Controls will be selected randomly using the lowest number. In our data set, if a case value is within one standard deviation of a control value, then it's considered a match. If a case value or control value are purported, these are known as discrete. In our sample values, two cases that received intervention cases were known as matching. We also had 7 cases which did not receive intervention. Patients were matched based on age. To simplify, they were classified as young or old. Now we will calculate the standard deviation of our data set. Here, to calculate standard deviation, you would type ST in Excel. This means standard deviation. And you will calculate here the ages. Once you have calculated the ages, you would have your standard deviation set. For case 1, which the age is 65, those with the standard deviation over are 2, 8, and 9. For case 3 matches, which the age is 64, those one standard deviation over are 4, 5, 6, and 7. For case 1, the lowest random numbers are 8 and 9. For case 3, the lowest random numbers are 4 and 6. The Kaplan estimator is used to report unusual outcomes in datasets. The number of patients at risk could be recalculated due to adverse outcomes, such as death, change, or dropouts, which are not affected in the calculations. Now we will compute the Kaplan-Meier plot for cases. The number of patients at risk for falling in the study and the number of patients that do not fall. This disparity or minus figure between the two will be calculated. To calculate the probability of the fallen, P or fallen in the previous time period times the conditional P or probability of none fallen. This will equal the probability for the data set for cases. Patients 1 and 3 are at risk. These are 2 cases. To calculate the controls, we will use the same formulas as we did for cases. The number of patients at risk for falling minus the number of patients that do not fall. This is calculated. Out of 7 control studies, only 4 cases have data that was collected in the 4-month study. A number of variables could have altered this outcome. For example, death or a patient moving away. Only 4 cases were at risk in this study. Here you will see the entire data set as computed. To find the percent of not fallen for cases, you would compute the previous percentage never fallen times the percentage or probability of those who have not fallen so far. That will give you your preceding or your next percent never fallen. For controls, the same will be computed, as you can see pointed by the green arrows. Once all data has been computed, you can now figure out the scatter plot for the Kaplan-Meier plot. I will not go into the details of how to compute this, but there's various internet resources to help you complete that. Thank you.